So everybody, today we have a speaker, Mike Ossmann. He is am I saying that correctly?
Yeah.
He's an awesome engineer. He has a shop up in Netherlands, which is a neat place to live.
Actually, Evergreen.
What's Evergreen?
Close. It's not the same elevation.
Yeah, some place way up in the mountains. You don't go to work when it snows.
Yeah.
So anyways, Mike's here. He's going to talk to you all about his projects and the neat company that he runs up in Evergreen. So without further ado, here you go.
Thank you, Dave.
Yeah.
Thanks for having me, everybody. I'm really excited to be here talking to y'all. And I run a little company called Gray Sky Gadgets, and I make things like this. This is Hacker F1, which is kind of like my biggest product, which is a software-defined radio platform. Have any of y'all heard of software-defined radio before? No? A little bit? No? Cool. Okay. So I'm going to tell you about kind of how I got started with electronics and software-defined radio and other things that I'm doing these days, so that you can kind of understand what these things are that I brought. So when I was a kid, I had one of these. Actually, my older brother had one of these. I kind of borrowed it and never gave it back. But yeah, it's a pretty cool kind of kit that a lot of kids had, like in the 70s and 80s, but I really lost interest in it pretty fast. Like it had a bunch of it had like a little project book, like build an AM radio and build this and build that, and every page would tell you like which wire to hook up to which spring, and I would like go through it and find something cool to build and follow it and put the wires in, and then the thing would work or it wouldn't, but I didn't really learn a lot from it, like because I didn't go further with it. I didn't like try to modify the things that were presented to me as a project. And the main reason I kind of lost interest in it, I think, is because these things happened. Like in the mid '80s, all of a sudden we had these affordable personal computers, and I got really into those. So I really was only briefly interested in electronics when I was a kid. I got into software really fast, and we used to have we used to share software or games or other things on floppy disks, and this was how you got software on your computer, and this is how you handed software to a friend. And I got into like sharing both software that I'd written and software that my friends had written, and also sharing commercial software that we used to copy. And some of this commercial software would have copy protection on it, and so like it was a challenge it was a fun challenge to figure out how to crack the copy protection, and so that you could duplicate some piece of software and somebody else, and they could run it. And we were constantly sharing software in this way, and this is kind of how I got into hacking was by breaking copy protection on things like this, and I really it kind of gave me an interest in computer security that I hadn't had before. And so over the years, I did more and more like software work and IT work, and starting from a very young age, and like through college, I paid my way through school by working in the computer labs and stuff like that. And I really identified a lot with the hacker culture, especially as I got older, and I kind of met more and more people who had similar backgrounds to me, and as the internet was growing, I was making contact with a lot of people all over the world, and finding out that there were a lot of people who shared similar interests. And professionally, I got more and more into computer security, and I used to do a lot of like penetration tests and security assessments for companies, and figuring out like where the weaknesses are in networks, figuring out how to break into their networks, break into their buildings, and all kinds of stuff like that. And ultimately, like was doing computer security work for several years. But a lot of different people have different ideas about what this word means, hackers. Like when I was a kid, or before I was a kid, a hacker was somebody who wrote computer programs. That's what a hacker was. a programmer. So if you've ever written a computer program or modified a computer program, which I would call hacking on a computer program, you're a hacker. And when I was a kid, that was changing a little bit. There were movies like war games, and we kind of saw people taking the more security angle, like breaking into systems or fixing systems. And all of these things are kind of part of what I see as hacker culture. To me, a hacker is anyone who finds pleasure in finding creative solutions to technical problems. That's to me the essence of being a hacker. But the people that I've known for many years that I consider to be hackers all kind of share some important traits. And one of them is that they share. They share information with each other. They share their software with each other. They share tools. They share things that sometimes maybe they shouldn't be sharing. But sharing is a very strong part of the culture, and open source is a big part of that. They program. Hackers look at a computer and think, I want to program that thing. How can I make it do what I want it to do? And that's very different from non-hackers. Like, non-hackers might pick up a piece of electronics and say, oh, this is cool, but it doesn't quite do what I want it to do, and to set it aside. A hacker will look at that and say, how can I make this do what I want it to do? And hackers really have a great respect for achievement. If you want to impress a hacker, the way to do that is to show them your own hack. And they love learning. They love learning new things. All kinds of different fields of interest are applicable to the hacker world. And hackers do tend to question authority a lot. But that doesn't necessarily mean they won't respect authority if they think there's a good reason for it. And hackers, and this may be the most important thing, all the hackers that I know really do, in some way, try to make the world a better place. And I think this is something that maybe is lost when the media writes about hackers, or movies portray hackers. Right? Hackers in general, in my experience, are the nicest people in the world and are always trying to make something more interesting, more useful, more entertaining. Whatever they're trying to do, they're trying to make the world a better place. So over the years, I did more and more of this kind of IT security work, and I found myself as a IT security officer at a hospital system here in Denver, but I was also kind of getting more involved in the hacker scene and doing a little bit of wireless security work, research and writing about wireless security tools and stuff. Wi-Fi, all Wi-Fi stuff, in the earlier days of Wi-Fi. And someone at a research lab saw some of that stuff I was doing and offered me a job working on things like this, which was a major leap for me. I was going from being responsible for network security in a large organization to figuring out how to hack the over-the-air interface and digital public safety radio systems. It was really quite a leap, but it was a fun leap, and I got to do pure research, and it was really an exciting time for me because I was learning a ton. I was surrounded by radio engineers who never really knew radio engineers up until that point. People who had PhDs in electronics, digital signal processing, stuff like that. And I was the one security IT kind of focused guy in this group of all these old school RF engineers who were doing research into public safety digital radio communication systems. And I used to do things like look through manuals or the specifications. Here's how the radio protocol is supposed to work. The handset sends such and such a message to the receiver or the central station, and it replies, and what do those messages contain, and how many bytes are they, and all this kind of stuff. And I would look for vulnerabilities just reading through the specification. And I would say hey, here on page 783, there's this there's this vulnerability where like anyone could transmit this message and it's unauthenticated, and it would just like shut down the radio. It would just stop working, break the thing. And people would look at that at me and they'd be like, yeah, right, like anyone could do that. Like, it's too hard, it's unrealistic. And that was frustrating for me because to me, looking at the specification, it was a clear weakness. But people didn't really take it seriously if I couldn't demonstrate it. And then one day somebody dropped a software-defined radio platform in my lap and said, hey Mike, what can you do with this thing? And a software-defined radio platform, now this is the one that I made, but the ones that we had 10 years ago were bigger and more expensive. But basically they do the same thing. And it's like a sound card, but for radio waves. You know, like your sound card can record any sound, and it can produce any sound, right? But if you've ever played like an old video game from the 80s or something like that, remember what those sounded like? You know, like they have a very limited range of sounds they can make because they have some special purpose chip that produces these sounds, or they have a general purpose chip that they've repurposed to produce sounds in some way, and it's not a very big range of things of sounds that an old digital system or even an analog system, well, I'm not going to get into analog. There's not very many sounds that an old digital system can record or reproduce or synthesize. But these days, we have these handy-dandy sound cards, and they have an analog to digital converter in them that lets them record arbitrary sounds and put them into digital form that then can be manipulated by software. And on the other side, they have a digital to analog converter that lets them produce arbitrary sounds. So you can record sounds, you can modify them, reproduce them, synthesize new sounds that no one's ever heard before. Sky's the limit. Like any sound your ear can hear can be produced by a sound card in your computer. And it's all done in software. Well, software-defined radio is basically the same thing, except instead of sound, it's radio waves. Instead of a microphone or a speaker, you have an antenna. And you just have to have a sound card that's like 1,000 times faster. And you can do the same kind of stuff and manipulate radio waves in software in a general purpose computer. And that's a super powerful tool. For me, back then when I was working on this stuff, that was an amazing tool because I had the ability, just handed to me, to build my own radio in software. And I was a software guy. Right? Like that excited me. Unfortunately, it was a lot harder than I thought it would be. I had to learn a lot about digital signal processing. Like there was a lot to doing software-defined radio that requires specialized knowledge beyond just knowing how to write some code. But I was surrounded by people who knew a thing or two about digital signal processing, and like they needed help installing Linux, and I needed help understanding Fourier transforms, and like, you know, it worked. I was able to learn a lot. And so I got into this, and I started being able to do things like give demonstrations. Here's what happens when somebody transmits an unauthorized, unauthenticated control message that can shut down one of these radios. And I could demonstrate it in real time, like here's a radio, use it, I attack it. Like that was practical. I was able to turn theoretical vulnerabilities into practical vulnerabilities. And it was extremely rewarding for me. And I liked it so much that I started doing this kind of stuff on the side, and I started playing with software-defined radio and kind of enhancing or doing more kind of wireless security research on my own just for fun. In particular, I started looking at Bluetooth because sniffing Bluetooth is hard. And at the time, it was especially hard because we don't have the tools that we've developed since then. A lot of people in the IT security industry do wireless security work where they like monitor Wi-Fi communications, and they check to see if there are any unauthorized wireless access points on a network, for example. They check to see that they're configured correctly so that they require authentication and stuff like that. So people all over the place are doing these wireless security assessments, and all they're doing is looking at Wi-Fi. But at the time, Bluetooth was getting pretty popular, And nobody was doing the same kind of security assessments on Bluetooth that they were on Wi-Fi. I knew companies, I worked for a company that had a policy that said no Bluetooth keyboards, not allowed here. But they did nothing to enforce that policy. They had no way to detect if there was a Bluetooth keyboard in their building. And so I got really interested in Bluetooth and trying to figure out ways around the problems that make Bluetooth hard to sniff. And one of those problems is that it frequency hops. It's jumping all around at different frequencies all the time in a way that's difficult to predict. And if you want to monitor it, you might need to, actually like hop along with it somehow. That's hard to do. But there were certain tricks that I figured out and other people figured out before me even. Notably Dominic Spills, who now works for me. Like I read a paper of his that he wrote on Bluetooth and we started collaborating. I started working with him to develop software-defined radio tools for Bluetooth security work. And eventually, I kind of came to the conclusion that like we actually presented some and published some work in that field, and nobody really used it. And I think the reason people didn't use it is because like we showed them how to take a $2,000 piece of software-defined radio equipment and then take a soldering iron to it, and then hack firmware on it, and then they could do something useful with it. And not a lot of people wanted to do that. So I started thinking, this shouldn't be this hard. Like instead of costing $2,000 plus, this should cost $100 or something like that. It should be just as easy as sniffing Wi-Fi, which you can do with off-the-shelf equipment. So I started thinking about how I would make a Bluetooth sniffer that anyone could put together themselves or buy. And I wanted it to be open source because everything I've ever done in my entire career that I'm proud of, it was something that I did with the help of open source software. So whatever I was going to do, it was going to be open source. It's just the right thing to do. And I started thinking more and more that this might actually require building a piece of electronics to do this thing. So how many of you all know what this is? Yeah? Ohm's Law?
Should be everybody.
Everybody?
We had
You
a
seen
lecture
Ohm's Law
on it
before?
like week 1.
I think some of you have seen this. It's a pretty important thing to know about electronics, and it really nicely sums up everything I knew about electronics at the time. I mean, really, this was pretty much it. Like, I had never programmed a microcontroller. I had never soldered a surface mount anything. I hadn't soldered anything in decades, and I had never designed any kind of a circuit ever. So but I can learn. And I really just set out to learn electronics just so that I could build a Bluetooth sniffer. That's what I wanted to do. I had an end goal in mind. Now I had to create many little smaller projects for myself along the way. Because I was like, well, I need to learn how to program a microcontroller. I should make a simple microcontroller project. I really need to learn how to do this. I should make a little project out of that. So I had a lot of little projects I made on the way, but the whole time I had this end goal in mind that I was going to make a Bluetooth sniffer. And I finally accomplished it. But along the way, I learned a lot of lessons. And at one point, I was trying to figure out what parts I would build this device out of. And there were some new chips that were coming out that weren't released yet. And I was like, ooh, one or two of those might be really good for this project, but I couldn't get documentation on them, I couldn't get sample parts, and so I tried to social engineer the companies. I created a fake company called Gray Scott Gadgets, and I drew this logo, and I made a website, and I sent them emails from grayscottgadgets.com and stuff, and I tried to pretend that I was actually a manufacturer of some kind of product that really didn't exist at all, and tried to get parts and documentation and stuff out of these chip vendors. It totally didn't work. This did not work at all. If I had pretended to be Intel or something, I might have gotten further. But this really didn't work. And but it didn't matter because I learned a lot of lessons, and I ended up building this thing called Goobertooth 1. It's a little USB dongle, and I failed to bring one with me because I thought it was in my bag, but it wasn't. But it happens to be the exact same size and shape and have a lot of similarities to this other board that I have. So I'm just going to pass that around. Goobertooth 1 was the world's first affordable Bluetooth sniffer. And it's just a little USB stick, you put an antenna on the end, and to detect Bluetooth signals that are otherwise undetectable. Like if you turn on your phone's Bluetooth, you could set it to be discoverable or not discoverable, right? Like, and if you set it to discoverable, then any other Bluetooth device can find it. If you set it to non-discoverable, no other Bluetooth device ever sees that it's there. But Goobertooth can. Right, that's the key thing that Goobertooth can do, is it can detect non-discoverable Bluetooth devices that are in use. And it's really just made out of like two main chips, this wireless transceiver chip and a microcontroller. That's it. It's pretty simple, but it was pretty ambitious. It took me a long time to get there, right? But once it was done, I had people saying like, "Hey, Mike, when can I buy this thing in a shop?" And I was, I don't know. It's open source. You can build it yourself. And they're like, "We don't want to build it ourselves." So I said, "Well, hey, I've got this company." So I actually like made Great Bad Gadgets a legitimate thing and started. And I put Goobertooth 1 on Kickstarter, and it was successfully funded. And I started doing manufacturing. And I started selling through resellers. And lo and behold, Great Bad Gadgets was born. This was about 5 years ago. And like within 6 months, I quit my day job at the research lab because I was selling so many Goobertooth and working on other projects that would hopefully turn into a commercial project. And one of those projects has to do with what I was doing earlier, which was software-defined radio. Right? Like I got into all this stuff because of software-defined radio, but Goobertooth 1 is not actually an SDR platform, not a software-defined radio platform. It's a hardware, like radio modem on a chip that I'm using. And but in the process, I started thinking more about what if I were to build my own software-defined radio platform? What if I were to make something more affordable, more general purpose, more portable than the things that were out already? Because I had this problem as I was kind of in this stage of my career. I was also doing a lot of wireless security research for fun and going to conferences like DEF CON, ShmooCon and stuff and talking about vulnerabilities in wireless communication systems. And for all the different kind of projects that I had different hardware. Like this is a cool tool, but it's a separate piece of hardware just for Bluetooth in my bag. So I kept buying other tools, and I kept buying this board for this project, and this thing for that project, and like my wallet looked like this, and my backpack looked like this, and my girlfriend looked like this, and I came to the conclusion that the world needs open source hardware for SDR because software-defined radio platform is a universal radio. It can transmit or receive any radio signal. I don't have to have all these different things in my bag I'm carrying around and dumping out every time I go through a TSA checkpoint. So I set out to make open source hardware software-defined radio platform, and the result was HackRF1, which I'll also pass around. Actually, I'll pass around two of them. This is like the original that, like in the enclosure and everything that I make. And this is one that has an add-on board that my friend Jared made for it. So this is the exact same board. It's just that he's put an add-on board in front of it that makes it a handheld platform with its own LCD panel that you can like walk around and do radio stuff in a handheld instead of having it be a peripheral attached to your computer, right? And this has been huge. This is like, I don't know, 80 or 90% of revenue of Gray Sky Gadgets now is HackRF1 because it's grown so much. It was also on Kickstarter, like 10 times more funding than Goobertooth 1 got. And that's been very important. Being able to do that crowdfunding has been extremely important because it's allowed me to self-fund my own business. Gray Sky Gadgets does exclusively open source. We only make open source things. And if I were to seek outside funding, I'm not sure that I would be able to stick to that principle anymore. If I were to give up some ownership in my own company, I might have to play by the rules of whoever owns my company, instead of playing by my own rules. My own rules are, I make everything open source. That's what I want to do, it's the right thing to do, and I can do that if I own my own company fully. And Kickstarter has really allowed me to do that. Crowdfunding has allowed me to build a company with the goals that I have, with the what's the word I'm looking for? Mission. The mission that I want.